Today's lesson's on classifying triangles. When classifying triangles, you classify by their angles and by their sides. When you're classifying by angles, if all three angles are acute, then you have an acute triangle. If one of the angles is obtuse, you have an obtuse triangle. If one of the angles is a right angle, it is a right triangle. And if all three angles are congruent, it is an equiangular triangle. Looking at this first example, it wants to know what these triangles are by their angles, and we're looking at CDE. So CDE, if you look at that triangle, you have one right angle, which would make this a right triangle. When classifying by sides, if all three sides are congruent, it is called an equilateral triangle. If two of the three sides are congruent, it is called isosceles. And if none of the sides are congruent to each other, it is called scalene. Now looking at this one, we have JKM. So JKM is the entire triangle here. JK is not the same distance as any of the other ones, and none of the triangle sides are the same. So this would be a scalene triangle. Most of the time, whenever you're asked to classify it by a triangle, you're going to classify it by both its angles and its sides. So looking at this example number 9, you see this one right angle and then these two sides that are congruent. Since it has that one right angle, it is a right triangle, and because of the two congruent sides, it is isosceles. So we would call this a right isosceles triangle. You can use the properties of these triangles in algebra problems as well. For example, here we have ABC is an equilateral triangle. Solve for both x and y. Since it's equilateral, that means all three of these sides have to be the same. Since we know that one of the sides is 49, that means all three sides are 49. So to solve for x, we can do 3x plus 1 equals to 49. Subtract 1 from both sides, gives you 3x equals to 48. Divide by 3, and x equals to 16. Solving for y, we just do 18y minus 41 equals to 49. Add 41 to both sides, and we get 18y equals to 90. Divide by 18, and we get y equals to 5. Looking at example 4, we have this is an isosceles triangle where DE is congruent to EF. We're supposed to find x and measure each side. Since we know those two segments are congruent, we can set those equal to each other. 8x minus 13 equals to 5y, or 5x, plus 17. We're going to subtract 5x from both sides. Gives me 3x minus 13 equals to 17. Add 13 to both sides, and 3x equals to 30. Divide by 3, and we get x equals to 10. Now we have to plug that back in for each of these, so I'm just going to plug straight here. 8 times 10 minus 13, this is 80 minus 13, which is 67. Now we know automatically that the other side would have to be 67 as well. We could also plug in and get the same value. Now for the bottom we would just do 10 plus 21, which would end up giving you 31. So DE equals to 67, EF equals to 67, and DF equals to 31.